Linear relations, linear graphs. All linear graphs are a straight line. We draw graphs on an XY coordinate plane. A plane is a two-dimensional object. It can be blank in two directions. It can be measured in two directions at the same time, but it has no depth. So a cube has three dimensions, and we live in a three-dimensional world. But a two-dimensional object, a plane, is completely flat with no third dimension, no depth. Each axis represents something. In the case of tile patterns, the x-axis represents the figure number, and the y-axis represents the number of tiles. When we draw the coordinate plane, we make sure to label the axes with both the names of the axes and the scale. Make sure that's scale. What scale we decide to choose depends on the relation we are graphing. For instance, on the scale for example 1, each square, that should be a square, not a quare. Whoops. Each square on the grid can represent one. I really messed this one up. Each square on the grid can represent one unit. All right, so let's graph example 1 here. So when I look at this, I notice that I'm starting in figure 0 with 3 tiles. So while I could put this x-axis kind of right in the middle here, it might make sense to drop it a little lower, like right there. That way, as I go up, I can see more of the graph that we're looking at. So I'm going to put right here. So that's my x-axis. So I label it with the name x. And my y-axis, there it is, that's y. Now for my scale, each square on the grid can represent one unit. So there's 5 units. And here's 10. And I don't have to put in every tick mark here. But when I put in a tick mark, it's sometimes helpful to label it. Not every time, but often. And then we should also label the x-axis. And it's okay if we don't label any negatives down here. We labeled this -5 on the x-axis. We don't have to label the y-axis, because as long as we have one place on each axis that is labeled, it determines the rest of them. It has to be consistent. So now we have figure 0 has 3 tiles. So here we have figure 0. Any point that would be on here would be figure 0, because my x-axis, so how we measure this way, represents the figure number. Figure 1, and this is 3 on the y-axis because there are 3 tiles in figure 0. Now figure 1 has 5, figure 2 has 7, figure 3 has 9, and we could continue on like that. And then we put in a line connecting those, and we can also continue down the other direction. So here we were going to the right one up 2, so we go to the left one down 2, and we can continue that way. Now we'll see that This doesn't make total sense when it comes to the tile pattern, but that's how we do lines. And we put these arrows on the end to say it goes on forever in that way. So there is our graph for that tile pattern in example 1. If we tried to let each square on the grid represent one unit in example 2, we wouldn't be able to see the y-intercept. And I'll show you that right now. So here we have a situation where figure 0 has, let's see, 3 times 4, that's 12, plus 2 is 14 tiles. So if I put, say, right here, then, and each grid was, each unit on the grid, or each square was one unit, 14 would be way up here, and we wouldn't see it. So we don't want to do that. So what we're going to do here is I'm going to make my x-axis down here again, and make sure to label it. And I put the label for the y-axis down here. It doesn't matter really where it goes. But this time I'm going to make each of the squares on my grid on the y-axis worth 2. So if I put a tick mark right there, that's 10, because 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. So this is going to be 20. And those are the number of tiles. There's 5. There's -5. All right, so figure 0 has 14. Figure 1, there are 3 less. So 9, oh, excuse me. I've got to remember my scale. 3 less is right there. Figure 2, 3 less. And it keeps going down like that. And I've got to make sure that I get it in the right place. It's really important. Because each grid is worth 2, this is 8. This distance right here is 3. All right. It continues to go down like that. And it can go up the other direction. And then we can connect those. Put on the arrows to say it goes on forever. It's important to understand that the line we draw on the graphs is continuous. That means that it is made up of points, of infinitely many points. Infinitely many points. So what you can think about is on this, there are all these points in here, and if we zoomed in between any 2 points, there would be infinitely many points in there as well. So, in a sense, the line doesn't make sense for the pattern, because while the point 1.56 is a point on the line in example 1, it doesn't make sense in terms of the tile pattern because there isn't a figure 1.5. So if we look up here, there's this point right here, and that point, oops, right here, and that point is the point 1.5, that's the x value, 6, that's the y value. So this would say figure number 1.5 would have 6 tiles. And we could see that since figure 1 has 5, and figure 2 has 7, figure 1.5 would have 6 tiles, but there's no figure 1.5. So although we make lines for these tile patterns, there's a way in which it doesn't quite work out. We only have figures that are whole numbers. We also don't have negative figures. So all this over here, this doesn't make sense either when it comes to the tile pattern.